Dear students, you can see today we are going to begin with the gravitation. In this particular topic, we are going to learn about the topic gravitation. As you can see here, in this topic, we are going to learn about the gravitation, Keplers Law, circular motion and the centripetal force, Newton's universal law of gravitation, acceleration due to gravity, force of the earth, free fall and escape velocity. First of all, we are going to talk about the gravitation. The phenomena of gravitation was discovered by the Sir Isaac Newton, and as everyone knows about, the earth attracts each and every object. You can see in this picture, in this you can see here the moon, the one of the object moon is having a force directly downward towards the center of the earth. Same way the apple you can observe over here, which is falling towards the earth. Now it's the force by which you can see here, the force is nothing but the gravitational force. The next part what we are going to learn is the force and motion. As already we studied about the force and the motion in the chapter 9th standard chapter, where we studied about the Newton's laws of motion. In that, three laws of motion already we had studied: the first, second and third. The first states what? That every object remains in the same state of motion or in a stationary state unless and until unbalanced force acts on it. And second one we studied, where it states that the force is equal to mass into acceleration. Third one we studied, where we studied that each and every action is having equal, opposite and instantaneous reaction. In this particular chapter, the next we are going to learn about the circular motion and the centripetal force. Whenever any particular object performs circular motion, means what? It means that whenever particular object is moving in a circular orbit, if you will observe the fan, where the tip of the fan's blade is performing a circular motion, or the Ferris wheel, giant wheel, this all what we have. If you will just take one of the point on the circumference of the circle, then you will observe that that particular object is moving in a circular form, and that kind of a motion is called as the circular motion. Whenever one particular object performs the circular motion, in that you can see this particular object is performing a circular motion like this. The top view they have shown over here, you can see here the top view, it's performing a circular motion. In this, if you will observe this inner one, this shows a centripetal force. The force which binds a particle with the center is nothing but the centripetal force. If you will see here, they have given a definition for the circular or the centripetal force. That centripetal force what we have is nothing but a force acts on any object moving along a circle, and it is directed toward the center of the circle. This is called the centripetal force. This is the definition for the centripetal force. Now the further is, if you will observe the circular motion, there is a force which holds it. It's just as an example, if I want to take it as if you are having a thread and you are tying a stone at one of the end of it, like suppose if you have a thread and here you are tying the stone and you are holding it from your hand from the side and you are rotating it, then this will start to perform a circular motion. Okay, This will perform a circular motion and you will feel a force which is binding it inward. That force is nothing but what? The centripetal force. Now, the next part is the Kepler's law, the most important law. The Kepler's law. Kepler has given a three laws. For that, if suppose you are having an ice cream cone, just invert it and slice it. This picture, this will show you how this one is. This one is cross sectioned in such a way that it gives you the elliptical form. This gives you the ellipse. If you will observe it, this is called as the ellipse. If you have a carrot at your home, you can try and slice it and just observe that shape. That shape is nothing but what? The ellipse. In this ellipse, if you will observe, we have a 2 points. The ellipse is having a 2 curvatures. The ellipse is having a 2 curvatures. The one curvature is this and the one curvature is this side. And according to this, these two curvatures are having a 2 focal points. You can see here the F1 and F2 they have marked. F1 and F2 are nothing but the focus. Like last year's in a light section, we had already studied about the mirror, and in that mirror already we have studied about the foci. In this particular topic, we are talking about the ellipse, and the ellipse is having a one specific property, and that specific property is nothing but, you can see over here, the F1 and F2 are 2 focal points of the ellipse shown in a figure, and these 3 points are on ellipse. Then if you will add up AF1, AF2, or if you are adding BF1 and BF2, same way if you are adding CF1 and CF2, you will get that all are equal. Now here, when I am talking about this equality, what does it mean? What does it mean actually? This means that if any particular point which is on the ellipse, like A, B and C, these points are equidistant. The distance of there from the two foci of the ellipse is nothing but the same or the constant. This is a property of the ellipse we have. Now we will move towards the Kepler's law. Kepler has given a 3 law. In that, the orbit, the first law, it states that the first law of the Kepler, it states that the orbit of a planet is an ellipse with the sun at one of the foci. What does it mean actually? Suppose if I am talking about planet A, this will be revolving around the sun in the elliptical orbit, and sun is at any one of the foci. Here they have shown at the F2. It can be here also. Any place is possible for it. Now, the next what we have to study is Kepler's second law. Kepler's second law, it states that the line joining the planet and the sun sweeps equal area in equal interval of time. This particular law, or this particular law by the Kepler, it states that what, or how it get explained by this. Let's see, check it out. If at one particular time, that time is t1, planet is at A, then at a time t2, planet reaches up to the B, then at a t3, object or the planet is at C, and T4 is nothing but the time where the object or the planet reaches up to a point D. Then if I am talking about the time T2 and T1, the difference between that is a 5 second or the 5 days. Same way, if the time difference between T3 and T4 is a 5 days means the time interval. If here I am talking about the time interval, that is the 5 days. Then the planet sweeps the equal area. This is a number 1, and suppose this one is number 2. Then the area 1 is equal to area 2. This 2 will be equal. Okay. This is about the Kepler's second law. Now, the next part is when we are going towards the next part, that is Kepler's third law. It's very simple. The square of its period of revolution around the sun is directly proportional to the cube of the mean distance of the planet from the sun. It means what? When there is a sun at the center, and the planet is revolving around it, the time required to complete one revolution, if it is complete in a time t, and the distance of the planet from the sun is r, then the square of this time will be directly proportional to the r cube. You can see here they have shown over here t square is directly proportional to r cube. So this is what the statement. If we will try to read the statement again, then we will observe it. It states the square of the period of revolution around the sun is directly proportional to the cube of the mean distance of the planet from the sun. So this is about the Kepler's law, Kepler's third law. Okay, so in this period, or in this video, I am just recording till the Kepler's law. Just go through it, and then we will go towards the next part, that is the Newton's universal law of gravitation.